start with the classification of hydrocarbons. This is the most important part. So now hydrocarbons, they are basically classified as aliphatic, and then next one is aromatic. And again, aliphatic compounds are classified as unsaturated and saturated, while aromatic compounds, they do not have any form of classification. As I said before, while talking about the aroma, which is the smell of compounds, aromatic compounds are a class of organic compounds which has a smell, like esters have a sweet smell, while aliphatic compounds not much are known to have any distinct smells. So now I know aliphatic compounds are known as unsaturated and saturated. So now under unsaturated, there are again two more types. So now there is known as alkenes and then alkynes. So what do you mean by alkenes? So now alkenes are supposed to be the aliphatic compounds which has a double bond. It has a double bond. By the way, before I start this, what do you mean by a bond? A bond is nothing but represented by a line, and this bond is supposed to be known to have two electrons. One bond has totally two electrons. So in case if I say a double bond is there, then it is represented by two lines. That means how many electrons are there? 1, 2, 3 and then 4. 4 electrons are there in this double bond. So now next one is nothing but an alkyne. What do you mean by an alkyne? An alkyne is supposed to be one which has 3 bonds, or you call it a triple bond. Triple bond in the sense 1, 2, 3. 3 bonds are supposed to be present in this. As I said, one bond has totally 2 electrons. So 3 bonds, 2, 4 and 6 electrons are supposed to be present in this triple bond. Why do you call this unsaturated? We call this unsaturated because in these compounds you can actually carry out certain reactions which is known as addition reaction. When you carry out addition reaction, the unsaturated nature of the aliphatic compound can be avoided. So now then it becomes saturated on adding such you can add bromine or chlorine, or any compound can be added by addition reaction. The unsaturated nature of the alkenes and alkynes, which is basically because of the double bond in alkenes and triple bond in alkynes, can be removed. So now the next one is supposing the name of saturated carbons. So what do you mean by saturated carbons? Saturated carbons is the one which has only a single bond, and this single bond is supposed to be referred as an alkane compounds. Alkane compounds are supposed to be the one which has a single bond. So if you ask examples of alkanes or a saturated compound, the most common example is methane, and then afterwards you have C2H6, which is methane. And in subsequent videos you will know how do you form the molecular formula for alkanes, alkenes and alkynes. So saturated compounds are the one which has only a single bond. Normally in such saturated compounds, addition reaction is not possible. Here you follow one more type of reaction known as substitution reaction. So let me write one reaction so that you will understand. For example, you have CH4, which is the most common alkane, a saturated carbon, and then you add Br2. The compound that you get is supposed to be CH3Br plus HBr. What most of us will do is we will write CH4 plus Br2 as CH2Br2 plus H2, which is completely wrong. This is not how you do, because here we do substitution reaction. What do you mean by substitution reaction? Here it totally 4 hydrogens and here it has become 3. Instead of the 4th hydrogen, you add a bromine here. So this substitution of 1 hydrogen has occurred. The product which is the substance which has substituted the hydrogen is a bromine. So now there's one more hydrogen left, and here there's one more bromine left. Hydrogen and bromine forms a hydrogen bromide. So normally they might ask questions saying when compound A reacts with bromine, it gives rise to compound B plus compound C, which is nothing but a basic compound, which is a basic reaction. Instead of asking you to write the reaction directly, they might represent the product as B and C and a reactant as A. So you need to know that and then if they say that this reaction is nothing but a substitution reaction, and they give you the fact this is a substitution reaction, then the only thing which you can use is supposed to be a saturated compound which belongs to aliphatic, which is nothing but any alkane can be used in A. So accordingly you will be getting a B, accordingly you will be getting a C. And there's one more thing, this B which you get, That means if a CH3Br can again, because it has more hydrogens, it can undergo more amount of substitution. So because of which again they can add Br2, and now only you get CH2Br2 plus HBr. You will not get CH2Br2 directly when you add bromine to methane. You will have to add bromine to methane. You will be getting CH3Br, and then add bromine again. You will be getting CH2Br2, the compound that I was talking about before, and then you will be getting HBr as usual. So depending on the product, depending on the reactant, the product also changes subsequently. So now these are the reactions regarding aliphatic. And now let's talk about aromatic. So now